Hello guys, welcome to my channel Phys-Ics. This is the branch of science that will be looking on mechanics. In this video, we will be looking at Newton's first law and the derivations of Newton's first law in terms of kinematics equations. Please stay with me here. If we remember very well, Newton defined his first law as he said that when an object is at rest, it will continue at its state of rest unless an external force acts upon it and it sets it into motion. And I came back to say, when the object is already moving with a constant speed, it will continue moving at its constant speed unless an external force acts upon it and it sets it to rest. Therefore, we look at parameters such as initial velocity, final velocity, initial position of the particle, final position of the particle, acceleration, and at large, we're looking at the time taken for all these parameters to correlate during a 1D motion. Therefore, if we have, so this is time, and it is calculated in seconds. If we can further elaborate the law that Newton is explaining in terms of the two statements above, he says that the particle, if it is at rest such that the initial position of the particle is xi is equals to 0 meters, the particle upon receiving an external force, it will move from initial position to some final position which we don't know. However, it relies on the magnitude of that external acceleration which it is called ax. So in this situation, the particle is moving in 1D such that we consider the linear motion in an x direction. So when an external force ax is being applied on the particle changes its position from initial to final position while it is raising its initial velocity from 0 meters per second to some final velocity vf. And if the particle is already moving at a specific velocity, and then it will continue moving at a constant speed unless an external force acts upon it and it sets it to rest. So what Newton wanted to look at, how long does it take for the particle to reach this time per second upon the application of the external force, and then he came back to say that how far the particle is going to go, it depends on the external force such that now how far the particle is going to raise its initial velocity from 0 to the final, it also depends on the magnitude of the external force. And then he came back to say that if we can analyze the average velocity of the particle, this would give us vf plus vi, and this would give us the average velocity of the object is by looking at how the position changes over the specific time interval. Therefore, he realized that these two equations, they are the same. Therefore, he equated the equations to say change in x over change in t is equals to vf plus vi divided by 2, and by cross multiplying, realize that the change in position can be found as long as you know the final velocity added to the initial velocity, divide by 2, and we just multiply by the t to find the first equation of kinematics. And then he came back again, he looked at the average velocity, the average acceleration, such that he was looking at the average external force, such that we look at the change in velocity over the change in time. And he said if we know the specifications of this equation such that we know the exact velocity, the initial velocity and the final velocity over a specific time, it will give us the specification of the magnitude of the external force. Therefore, from this situation, it just came down to say if you just cross multiply that change in t, it will give us a change in t vf minus vi. Taking the negative of the initial velocity to the left hand side, it leaves us with vf is equals to vi plus a change in t, and this gave us the second equation of kinematics. And then he said if you substitute equation 2 into equation 1, such that he derived that substituting equation 2 into equation 1, that will give us, so he took equation 1 as it is and he wrote it down to be Vi divided by 2 multiplied by changing t. Therefore, from this situation, it was a case that he substituted Vf because equation 2 is given by Vf is equals to Vi a changing t. Therefore, he substituted Vi with Vf with Vi plus a changing t, and plus that Vi all divided by 2 multiplied by changing t. Therefore, from this situation, it just added the initial velocity, and the initial velocity they gave him 2 Vi plus a changing t divided by 2, and they multiply the changing t which is outside the bracket inside the bracket, and that gave 2 Vi changing t plus a changing t squared all divided by 2. And from this situation, just came back to say if we resolve the situation of the LCD from the denominator, 2 and 2 is gonna go out, leaving us with Vi changing t plus 1 over 2 a changing t squared. And then he concluded that this is the equation, is the third equation of kinematics. And for the fourth one, he went back again to the same average acceleration, such that we're looking at changing velocity over a specific time. And then he said if we know the specification of this, the actual acceleration will be given by Vf minus Vi divided by changing t. And if we make changing t the subject of the equation from this situation, you will have changing t is equals to Vf minus Vi over a. And it took this situation, it took this equation, and he said that if we take this and substitute, so he said we can take EQ and substitute into equation 1 again, such that equation 1 it is given by changing x is equals to Vf plus Vi divided by 2 multiplied by changing t. And now instead of changing t there, he said let us put Vf plus Vi over 2, and we substitute changing t with Vf minus Vi divided by a. And from this situation, he said that the changing x can be written in terms of, he now dealt with the denominator which is 2 multiplied by a, and he multiplied by 2 multiplied 2a throughout the numerator, such that this will give us, on the left hand side it will give us 2a changing x, and on this side will be remaining with Vf plus Vi, Vf minus Vi. So he said that if we multiply both brackets, we will use the FOIL method, such that this will multiply in this fashion from the top, and this will give us on the left 2a changing x. The right hand side, it is given by Vf squared plus, no, it's negative because it's Vf Vi, so it's minus Vf Vi plus Vf Vi when we do this guy, and then that one gives us minus Vi squared. So we realize that we have like terms, it's negative added to positive gives us 0, therefore we have Vf squared minus Vi squared, and on the left hand side we still have 2a changing x. And he said if we take the negative of the initial velocity squared into the left hand side, we will have Vf squared being equals to the initial Vi squared plus 2a changing x. And from this situation, realize that he found the fourth equation of kinematics. So for a quick recap, equation of kinematics, which is given by the final velocity plus the initial velocity divided by 2 multiplied by the time or change in time. And the second equation, it was given by the final velocity is equals to the initial velocity plus the external force A multiplied by t. And third equation, and I will write it as VF squared VI squared plus 2a changing x, and again changing x is given by VI changing t plus 1 over 2a changing t squared. And these equations are known as the equations of kinematics for 1D motion of a particle or an object. So Newton utilized these equations to analyze a motion of a particle that is moving in one dimension. So guys, that's all for this video. If you find this video helpful, please do subscribe and do not forget to hit the notification and the like button for more of this content. Thank you everyone. God bless you.